Okay, I thought I'd give you a little perspective on where this function comes from right here. This is what we call exponential decay because this base is between 0 and 1. Just think about how much value the car would have after 1 year. How would you calculate that? Well, you take 7% of the current value because it's going down by 7% per year, and then you subtract that from the original value, and that would give you $16,740. It's gone down by 7%. But if you picture factoring out an 18,000 from these two terms, you get 18,000 times 1 minus 0.07, and 1 minus 0.07 is 0.93. And if you multiply 0.93 times 18,000, you get the same number, 16,740. This 0.93, when you multiply by that, you went down by 7%, so the 0.93 is what's left after 1 year. And if we keep multiplying by 0.93, this represents what was left by after 1 year. And if we multiply by another 0.93, that'll be what the value is after 2 years. And another 0.93, that'll be left with what the value of the car is after 3 years. And so the function, the exponential decay function, is the initial value of the car, 18,000, times 0.93 to the x power or the t power. You could use t for time. But so after 0 years, the car has an initial value of 18,000 because 0.93 to the 0 power is 1. 1 times 18,000 is 18,000. And then here's the values of the car after 1, 2, 3, 4, and so many years. It's called exponential decay. We can see that it's going to reach 8,500 somewhere between 10 and 11 years. Question is, how do you figure out the value for x using a calculator? So we'll go to board 2. Here's the exponential decay function, and I'll use f of t, 18,000 times 0.93 to the t power. We want to know, when is this function value going to be 8,500? So 8,500 equals 18,000 times 0.93 to the t power. Now we're solving an exponential equation. We've got a variable in the exponent. I would say let's isolate this factor right here by dividing both sides by 18,000. And of course, 2 of these zeros cancel out. So we've got 85 over 180 equals 0.93 to the t. And here is where you have to use the properties of logarithms to solve for t. You take the natural log of both sides, 85 over 180, and you take the natural log of this expression, the point is you can bring this t with using properties of logarithms down in front. So we've got the natural log of 85 divided by 180 equals t times the natural log of 0.93. So finally, t equals whatever this number is divided by whatever this number is. And so we've got the natural log of 85 over 180 divided by the natural log of 0.93. And I think if you do that on a calculator, you'll see you get something like 10.33 Of course, it goes on for a while, but to the nearest tenth, it's going to be 10.3. Okay, there you go. Hope that helped. If you have any questions, post a comment.